circuits homework number 1, the handout number 1, problems 27, 28, and 29. Basically simplifying these circuits. They're not complete circuits yet because they don't have batteries hooked up. For example, in number 27, you'd put a battery between these two, where these two little circles are. That's where your potential difference or battery would be placed. That's implied here. And then in number 28, you put a wire from here to a battery rate, say right here to there. Well, I should go to the original diagram. From here to here would be where the battery would be placed. And for this last one, the battery would go down here and across, or from here, the wire would go up to a battery there and down there. So this is just a network of resistors that are in a combination of series and parallel connections. And a lot of this comes with practice. And draw the diagrams. So these you just have to simply combine and find the equivalent overall resistance. So in this first one up here, number 27, one of the common mistakes in number 27 is to think that this 10 right here, the 10s that are parallel lines, this 10, and this 10 are in parallel. They are not in parallel with each other. These three 10s in the middle here are not in parallel. They would be if this one, this one, this one, and this one were not there. But because those resistors that I'm pointing at, that one, and that one are in this circuit, the three 10s in the middle are not in parallel. So the place you have to start here in this problem is out here. This is a junction right here, and from this junction around this road, this path to this junction, that's one wire, one road with three resistors. So those are definitely in series. That's an easy combination, so I did that new diagram, do these step by step, draw the diagrams. So the only simplification I did so far in this one is to add 10 plus 10 plus 10 is 30. You don't need to show work, just show the diagram. So there's my new resistor that replaces the three 10s. Once you do that, now you might be able to see more clearly that this 30 is in parallel with this 10. In other words, we have a junction right here and a junction right here, and there are two pathways as of now, simple pathways. From here to here is the 10 ohms, and from here around this way to there is the 30 ohms. So that and that are definitely in parallel. If you want to get more advanced, these two are in parallel, then all of these together would be the third thing that's in parallel with those, but don't worry about that right now. These two are clearly in parallel with each other. That's all I got to worry about right now. So the way you combine this 10 and this 30 is by the math over here. 1 over the 10 plus 1 over the 30 equals 1 over your total. And I'm leaving that for you to do. And this would be the new diagram then. You would combine the 30 and the 10 into one resistor, leaving the other 5 10 ohm resistors still in place that are from the original. But now the diagram is getting simpler and simpler. And I think you can see how you move forward here. Once you get this answer, and say I'll take a guess. It's around 5 ohms. It's a little bit more than 5 ohms. But let's say it was 5 ohms. Then these three together, you draw a new diagram, you can just do the work in your head, but 10 plus 10 plus 5, because they're in series, would give you, like, say, 25 ohms-ish. It's going to be a little bit more than that. And then when you draw that diagram, you'll have to draw that diagram. You'll have more space than I have here. Then whatever that is, say it's 25, that would be in parallel with this. And then you would use the 1 over rule to combine that 25 ohms with the 10. And then the final step, the final diagram, would be these three in series then once you have. Right now, these three are not in series. You got to combine out here first before you bring it all back into here. And then once you have those three resistors left, this one and then the replacement out here, and this one, then those are in series. So you have, let's see, 1, 2, 3 more diagrams you have to draw for this. 3 more diagrams for this one. Number 28, it's not real obvious, but this spot right here and this spot are the same spot. That's one junction right along here. That wire, you can collapse all of that into one. That's one spot. That's one connection. Same thing over here. So they just threw this in here diagonally, not to trick you, but just to show you that it doesn't matter how you hook these up. All of this along here is one spot. In other words, once again, if you were taking a walk or a drive and you went this way, you get to this spot, how many ways are there to get to the far hand right side of this diagram? Well, there's this pathway up through there and across. I could start here and go this way, down and across. And I could start here and go this way, across and across. So there's 3 pathways. These 3 here are in parallel with each other. They're in parallel with each other. So that's where we start with this problem. There's no hard and fast rule that says you start always with parallel or start always with series, but this is the case here. These are in parallel. That's where you have to start, basically. You have to start there. So you do the 1 over the 6 plus 1 over 6 plus 1 over 6. I show the math way over here to the right. And then you get the replacement. And I think once you draw the second diagram here, there's only one more new diagram. There's only 2 diagrams for this problem. This is the diagram that replaces the first replacement. Once you get that answer, and I know it's less than 6 ohms, I'll tell you that. It's actually less than 4 ohms. You can figure it out. Whatever it is, then the final diagram will just be these 6 plus whatever that is plus 6 gives you the total final resistance combined. That's one more step. This one at the bottom, there is, once again, a lot of complications here in this problem. But the place you must start in this problem are with these two. If I'm at this junction right here, this junction, and I want to get to this junction, there are 2 ways to get there. If I'm moving forward, if I'm moving across this way to that spot and it can never back up, this is in series with something. Actually, this one is in series with everything. This resistor here is in series with all this entire connection over here. But anyways, if I'm at this junction spot, okay, I can go this way to get to that spot, or I can go up and over to get to that spot. I am not allowed to go down, over, and go backwards into that spot. So that's why this is not in parallel, at least not yet, with these two. Well, it's not in parallel with these two. This one actually is in parallel with a combination of all 3 of these. So what you do is you combine the 3s here like I did over there in the green. So this green R is the sum total of resistance, the combined resistance of these 2 3s over here. I think then what you'll see is you'll have 3 more diagrams. You're going to draw these 2 together. So once you have this, say it's 2 ohms, then you draw your new diagram where you combine these 2, make a 5 ohm or whatever that is. And then whatever that resistor is that you'll put right there in your new diagram, combining these 2, will be in parallel with that. So it'll be 1 over 3 plus 1 over whatever that is. Will give you the combination of that, and you'll replace all of these within that one resistor, which will then be in series with this. So you have 1, 2, 3 more diagrams for this particular problem. You have to combine these for one new diagram. You combine this with that for a second new diagram, and then combine all of that with this for your third new diagram. Good luck.